Hello. So today we're going to take a look at imaginary numbers. This is where a lot of students jump off the math track and say, okay, if the numbers are getting imaginary, I'm out of here. But stick around because it's actually really fascinating. Let's go. Okay, so imaginary numbers. The easy part, we describe them with the letter I. And what I means is the square root of -1. Okay, now why is that imaginary? Well, when we have something like the square root of 4, that's asking the question, what times itself equals 4? And so there are two answers to that question. 2 times 2 equals 4, and -2 times -2 equals 4, because a positive times a positive equals a positive, and a negative times a negative equals a positive. However, to create a negative number, we need a positive times a negative or a negative times a positive, which means there is no answer to the question, what times itself equals negative anything? However, there are many instances of real math that require us to take the square root of a negative number. And so we've created this variable I as almost a placeholder to express the concept of the square root of a negative number, which can't be and therefore is imaginary. Okay, now let's talk about how to work with imaginary numbers. So I is the square root of -1. I squared would therefore be the square root of -1 squared. And when we square the square root of something, we essentially remove the square root. Therefore, I squared would just be -1. I to the third could be described as I squared times I, right? When we multiply with exponents, we add their exponents. If that's not familiar, go take a look at this video. And so then if we substitute -1 in for our I squared, -1 times I, we find that I to the third just equals -I. And finally, I to the fourth could be rewritten as I squared times I squared. Again, remember, 2 plus 2 equals 4. And since I squared is -1 and I squared is -1, that's -1 times -1, or 1. And that pattern repeats every 4, because you can see I to the fifth would be I to the fourth times I. I to the fourth is just 1 times I, or I. I to the sixth could be rewritten as I to the fourth times I squared, or just I squared. I to the seventh equals I to the fourth times I to the third, or I to the third. And I to the fourth times I to the fourth could be rewritten just as I to the fourth. And this pattern will continue every 4. So when we have something like I to the 431st, here's how we simplify. Step 1, divide by 4. All right, 4 goes into 4 one time, bring down the 3. 4 goes into 3 0 times, bring down the 1. 4 goes into 31 7 times, and our remainder is 3. Now, we don't actually care about how many I to the fourths there are. What we care about is the remainder, because from there we go back up to the top and we count 3. I to the 1, I to the 2, I to the 3. And so this reduces to I to the 3, because we will have 107 I to the fourths. That's 1 times itself 107 times. And then an additional I to the second, I to the third, which we can see farther reduces to -I. So now that you understand the how come, we can jump straight to the what to do when you are facing I to the enormous number. Divide by 4, find the remainder, and then if your remainder is 1, your answer is I. If your remainder is 2, that's I squared, which is -1. If your remainder is 3, that's I to the third, which is -I. And if your remainder is 0, that means there were an even number of I to the fourths. That means it reduces to 1. Got it? Okay, let's look at how you multiply with I. Okay, so here This is called a complex number because it is in the form a plus bi. And this is also a complex number where here our b is just -3. So we have two complex numbers and we're asked to multiply them. So we're going to FOIL, just like we would as if this were an x. If FOILing isn't familiar to you, go take a look at this video. Otherwise, let's go ahead. Firsts, 4 times 1, or 4. Outsides, outsides meaning closest to the outside of this whole set, 4 times -3i. Insides, meaning closest to each other, 6i times 1. And finally, lasts, meaning the last in each set of parentheses, 6i times -3i. Well, 6 times -3 is -18, and I times I is I squared. I always take this step and write the I squared in. Now on the next step, I'm going to substitute because what does I squared equal? That's right, -1. -18 times -1 or plus 18. Okay, I can combine my middle terms. -12i plus 6i. Use cow math. If you have -12 cows and you add 6 cows, you have -6 cows. Same thing with i's. And then finally, we've got our 4 on the outside, and I can combine 4 and 18 to get 22 minus 6i, and that's in my a plus bi form. Okay, that is your introduction to imaginary numbers. Take a look at some of my other videos using imaginary numbers and specifically how to find imaginary answers to your parabolas, your quadratic equations. Consider subscribing to my channel so you see when I put out a new video. And as always, keep on mathing.